Alright, so let's break this word apart. So photo is actually a photon, and photons correspond with light. And a catalyst is just a material that changes the rate of a reaction. So a photocatalyst is a material that changes the rate of a chemical reaction once it's exposed to light. A semiconductor is a material that is able to conduct electricity, but not as well as a proper metal. A photocatalyst is often going to be a semiconductor, since it actually needs to be able to conduct that light energy, or that solar energy, to convert it into chemical energy. Photocatalysis is the phenomenon where an electron-hole pair is created once the semiconductor or the photocatalyst is exposed to light. This happens due to photoexcitation. When you have the artificial light going through the semiconductor, what happens is that those photons heat up those atoms. Inside of the atoms are electrons, which are moving at an accelerated rate due to this excitation. When these electrons get excited, they jump to the next energy level. And once they jump, this creates another electron and a hole in its place. Since this is happening to thousands of electrons at a time, these electrons are breaking from their valence band to a conduction band, breaking those covalent bonds as they jump energy level to energy level. What this causes in turn is for the electrons to fall into the holes the other electrons have created, going back into their valence bands. What happens is that solar energy is converted into chemical energy, which drives the reaction and produces hydroxyl radicals. They can be used to treat kidney stones, gastrointestinal disorders, respiratory and bronchial diseases, and more. It can lower the CO2 emissions, since hydrogen is a renewable energy source. In addition, it's used for air purification and water purification, which obviously helps the environment. There's no negative environmental factor in photocatalysis.